Hello guys, welcome to the channel. Today we will discuss multi-class classification. So what is multi-class classification? Multi-class classification is a type of classification where target or output has more than two classes or categories. Okay, what it means? We saw in our previous video in binary classification have we always have two categories in our output. Okay, but in multi-class classification, we will have more than two categories or classes in our output. Suppose I have some problems like animal detection. So I have these classes in my output, cat, dog, horse. In exam grade prediction, I have A, B, C, D, more than two. Flower prediction for iris dataset, we have three categories, right? So basically in multi-class classification, we will always have more than two categories, right? So you can understand the basic difference between binary classification and multi-class classification by this graph. In binary classification, there are only two classes, and in my multi-class classification, there are multiple classes, more than two classes, right? Now, now when we use logistic regression algorithm for multi-class classification, we can basically logistic regression can apply by logistic regression we can apply a total three approaches for our multi-class classification problem. Okay, first one is multinomial method, one versus rest, OVR method, and direct method. Direct method generally, which already we saw how to like apply logistic regression directly. Okay, so first one, what first method do? Multinomial method. Multinomial method basically it all basically it handles all classes at the same time. All the classes. Suppose I have three classes, total three type of categories in my output column. It will basically treat all the classes at the same time. Okay, instead of creating new models for all classes. Okay, class one, class two, class three simultaneously. Okay. Now, suppose these are my classes in my iris dataset. I will show you the dataset. On this dataset, we will perform our logistic regression algorithm. This is the type of multi-class classification because see, here we are three categories in our output column, and these are its input columns. Four input columns and one output column, right? So we will apply on this, and this has three categories. So it comes under multi-class classification, right? So what it does, it will directly calculate probabilities for all three classes together. Suppose I got 90% probability for Setosa flower, and it will be higher than other two. Then our prediction will be Setosa because it has higher probability, right? So this is how multinomial method works. First, understand by theory. I will explain it by doing practically, but first understand it by theory. Okay. Second one is one versus rest, OVR method. The name itself suggesting OVR, one versus rest, means one class versus all remaining classes. For example, suppose I have three classes. It will create three different models, right? Three different models because I have three classes. If I will have four classes, then it will create four models. So first model will Satosa versus other, second class versus other, model three, third class versus other two classes. And this is how it works. OVR method. Okay, one versus rest method. Okay. The name itself suggesting what it does. Okay. Direct method basically just apply logistic regression to you for your training data and test the model. Okay. So we will see how we can do it using Python. Okay. So first, look at the data set. On this data set, we will apply my logistic regression algorithm for all three approaches. And I have already explained why it comes under multi-class classification because it has three categories. Output column has three categories, more than two categories. Okay, so I will do it of its practical part. First, I will import some required libraries. Import pandas as 3D. Import matplotlib dot pyplot as plt. Import seaborn as SNS. Okay. Now, now I will load my data set. Data is equal to pd.read slash csv because I have csv file. If you have Excel file, then you can write Excel. By the way, I will give you the data set. Copy path, control V. Now write. Check its first three rows. My data is loaded or not. Yeah, it is taking some time. Yeah, my data gets loaded and these are its first three rows. So my data gets loaded. Now I will show you its unique values. Means what are the unique values in the output column. Okay, data dot unique. Okay, so these are three different categories. These are three different categories of flowers we have in our output, and these are its input columns. On basis of these input columns, it affects our output, right? It will like decide my flower is setosa or versicolor, anything, any flower. Okay. Now I will show you by plotting a pair plot how it is looking like uh, on these four inputs. I will show you. Data is equal to data because I have loaded my data set in data variable is equal to spaces I will give. Okay, of plt dot show. Now first look at the colors. Okay, setosa for blue, versicolor for green, sorry orange, and green for virginica. So these are three different colors for different categories, different species of flowers. Okay, now look at sepal length, sepal width, and petal length, petal width. Okay, these are the four basically inputs. These are the four inputs. Okay, so how it is looking like? Look at this. For sepal length, it has higher values. Means I have higher setosa for this. Look at this. This is how it's looking like, right? So I have shown you the how it is looking like, how it is separated, how it is like, how it is looking like into my graph. Okay, so now I will separate my data into input and output. I will use ilog. I will say give me all rows and give me all column, but don't give me the last column -1. Last column because this is my output column and I will take my output column into Y. All the input columns I have taken in X and In Y, I am taking output column. Okay. Now, now I will now I will divide the data set into training and testing data. Right. First, I will import train test split from scalar dot model selection, import train test split. Okay. Now, now I will take my all four variables: x train, x test, y train. These are the things I have already discussed. You can check my previous video of train test split is equal to. I will call my train test split for which variable x and y, right? Now I'm taking test size as 20%. I want 80% for my training data and 20% for testing data. So I will write test size is equal to 0.2 random state is equal to 42. Okay, now my data gets divided into training data and testing data. Now, first method was my multinomial method, right? Multinomial method. We will see that. I will give a markdown here. Multinomial method. I will choose markdown and shift plus enter. Now, my multinomial method. I will first give, first I will import logistic regression, Scikit-learn dot model selection, sorry, linear model, linear model, import logistic regression. Okay. Oh, some spelling mistake. Okay. Okay. Now, suppose I will give an object to call my logistic regression. Now, here for multinomial method, because we are not applying a direct method, we are applying multinomial method. I will have to give, suppose, shift plus tab use. Now, see, here you have to use solver. Solver. Okay. For multinomial method, we will use this solver because this solver is fast, stable, and supports multinomial losses. Okay, this is because of it we are using this solver. Okay, now again when you will click shift plus tab, you will click here, then you will get this. Okay, max iteration. Suppose I will give 1,000. Let's say I will give 1,000. Basically, max iteration, if I will give 1,000, it will allow our model to train longer. Okay, this is what it means. Okay, I have explained both of this. Okay, So now shift plus enter. Now, now fit your training data for your model X train, comma Y train. Okay. Now my data model gets trained by my training data. Okay. Now suppose I will check accuracy of my model, comma Y test. See, it is giving 100% accuracy. Okay. It is giving 100% accuracy because this data is very good data, iris data set. This is because uh, that's why we are getting 100% accuracy. See, we looked how multinomial method works, how we can use multinomial method, okay, and why it is used. Okay, now we will see OVR method. Okay, OVR method. Now, for first, again, I will give a mark now for using OVR method because I will give you the notes also. OVR method. For using OVR method, we will first have to import one versus rest classifier. Okay, from sklearn dot multiclass import one versus rest classifier. Okay, now suppose I will give a second object lr2 is equal to I will call my rest one versus rest classifier. Now in this I will use logistic regression. I will use my logistic regression. Okay. Now, now in this we will suppose I will check shift plus tab. Now in this we will give our solver is our solver as lib linear. Okay. Suppose I will take this. I will take lib linear in why lib linear because linear basically works better for binary classification. Okay, binary classification means see what OBR method does. I've already explained one versus rest. For basically three classes, it will build it will build basically three different models, and in one model, it will it will check one class versus others, right? So that's why we are taking solver is equal to linear. It is better for binary classification. And I will again take max iteration as max iteration at 1000 so that my model gets trained longer. Okay. So if plus enter now. Now I will fit my uh, training data for my OVR method. Dot fit X test Y test. No, it gets fitted. Okay. Now, now I will check the accuracy again. LR2 dot score. I will give my X test, comma Y test, hit plus enter. Yeah, it is giving 86% accuracy. It is not that much good accuracy, but yeah, I'm getting 86% accuracy in my OVR method. Okay, so for now, for my model, multinomial method is good. So from OVR method, we are getting slightly low accuracy. Now, direct method. Direct method is very simple. Just apply your logistic regression. Okay, I will give markdown, shift plus enter. Now, LR3 is equal to call your logistic regression. Okay, now fit your training data, X train, Y train. Now, check the accuracy. 3 dot score. We will give X test, comma Y test into 100. So it is also giving me 100% accuracy. So we saw how we can use different methods of logistic regression for multi-class classification. Okay, so we have seen all three methods for multi-class classification by logistic regression. Okay, so that's all in this video. For the next video, we will discuss confusion matrix. Okay, thank you.